All right, here's a review for section 4.5, using graphs to estimate values. This should be pretty easy as well. It's very visual. I don't think that there's a lot of actual physical calculations you're going to need to do with your mind or your calculator or writing stuff down. Honestly, you're just looking at the graph. But what you should do to show your work on a test, exam, assignment like this is you should show on the graph where your solutions are. So just little pencil marks. I'll show you exactly how to do this. This graph represents a linear relation to determine the value of x for each value of y. Okay, so when y equals 1, what I have to do is I have to go over to the y-axis. That's the vertical one. So I'm going to find 1 right here. And I'm going to find out what the x value is for the y value that touches this line. Well, the point here is 0, 1, right? So it looks like x equals 0. X equals 0 for A, for number 1. Okay. For 1A2, y equals 3. So I'm going to go up to 3, and I'm going to go over till I hit the graph, and boom, I'm going to stop, and then I'm going to drop right down. And what is that x value down here? 4. Yeah, x equals 4. Excellent. When y equals 0, that is the x-axis really. It's right here. So what is this point? What's the x value here? Negative 2. X equals negative 2. Awesome. And if they just have 0, 4, negative 2, that's fine. You don't have to put x equals, I guess. Ideally, you would. Determine the value for y now for each of these values of x. So when x equals 2, I go over to x equals 2 right here, and I look at this vertical line, and I go up until I hit the graph, and then what's the y value associated there? 2. Yeah, y equals 2. Very good. Thanks for helping me out, shouting out those answers. Very good. When x equals 8, oh my goodness, x equals 8. Can't do it. Can't do it. Do you know what? We can't do it, right? I don't see x equals 8 on here anywhere. So we just skip it, right?
Yep.
No. No, that is the wrong answer. But thank you for answering. You're totally wrong. We don't skip it. Can we do something like extrapolate?
Whoa.
Remember extrapolate? Extrapolate. So let's project into the future here. So this is 6. This would be 8 over here. Okay. So I'm going to extend this line, and I guess it looks like it should intercept right about there. Does that look about right, or no? Yeah?
Yes.
Okay. So this is x equals 8. What y value would that be? It's going to be this right here. So I have to extend again, 2, 3, 4, and this would going to be, does it look like 5? 1, 2, 3, 4, 5. So guess what? 8 is attached with y equals 5. I like it. X equals negative 6. Oh, got to skip this one too. It's not on the graph, right? Wrong. Okay, negative 2, negative 4, negative 6 right here. So I got to figure out where the graph would be. It's going to be down here somewhere. Look at that. What's that?
Negative 2.
Negative 2. Okay, so y equals negative 2. Awesome. I'll do that in red. Negative 2 for 3. Everybody good? Okay. All right. This graph represents a linear relation. Determine the values. Again, so on. So I'm not going to probably spend as much time on here. So when y equals 3, I go over here, and that's x equals 1. When y equals negative 2, that's x equals, ooh, got to be careful there. Negative 2 is going to be negative 1.5. And when y equals 7, ooh, I got to extrapolate here. We're going to have, looks like 1, 2, looks like it might be 3 here. 4, 5, 6, 7. Yep. See that? So it's going to be x equals 3. All right, determine the y value. So here for first one, y equals 1. And then y equals negative 3. And, whoops, where'd my 1 go? And then y equals negative 7 if you extrapolate there. Okay? Got it? And agree or disagree? Maybe I'll get rid of my little circles so you can see a bit clearer. 2, 5, negative 2 for 1b. All right. 3. Is it the same thing? This is the same thing. We may have to extrapolate here again. Okay, so for 3a, let's do this. So x, for y equals 2, x equals, shout it out, anybody know? 2, y equals 1. Yep. For this one, we've got x equals -1, and we've got x equals, looks like 4 for 5. So 1, 2, 3, 4, 5. We really have to extend here, don't we? Let me see. Oh, that's y equals 5. Sorry, 2, 3, 4, 5. Right here. So this one is going to be 1, 2, 3, 4. Beauty. B, 3b, it's going to be y equals 1. The second one's going to be y equals 4, and y equals -4. Questions? All right. Finally, last question, number 4. The graph shows how the cost of a long distance call changes with the time for the call. So we've got cost on the dependent axis here, depends upon the time. All right. So if you look closely at this graph, you should know that there appears to be some kind of flat rate. And the flat rate or the starting fee is sort of where this starts on the y-axis, the cost at 0 time. So when you pick up the phone, start to dial, you already owe money before the time even starts, like as soon as you make that call. And what's that going to be? Can we tell here? This is $0.5. So there's 1, 2, 3, 4, 5 sections there. So yeah, it's going to be 20 cents or $0.2, so 20 cents there. So it starts at 20 cents. Awesome. That might be a question later. I don't know. Estimate the cost of a 7-minute call. So a 7-minute call, you're going to, whoops, I'm going the wrong way. Zoom, please. A 7-minute call, we may have to interpolate. That means, get information from in between points. We don't really know any points here, we just have this line. So 5, 6, 7, looks like this is 7. So we go up there, and what is that right there? So you want to guess about 55, 56 cents maybe. I'm guessing a really good estimate there, because it looks like it's just above halfway in between.
58.
Yeah, I'll take I'll take anywhere from 55 to 58. Okay, that's correct. So 55 to 58 is fine. So 0.55 to 0.58. That's probably reasonable. It should be about 0.56, I would say.
Did you get like a 0.5 per foot 60?
No, just circle it. Circle it. They don't have anywhere in between here. Is this interpolation or extrapolation? Explain. Would this be inside the graph, the points that we can see? Yeah, this would be inside. Remember, extrapolate is beyond the graph. So this is interpolation, and your explanation, again, should be on a separate piece of paper. It should have, it's inside the graph. It's within the line.
What if they didn't explain?
Well, then you could circle the explain part, and I'll take a look at that and assess some part marks. All right, the cost of the call was $1. Okay, so here's $1. I guess I need to find out where this graph would connect at the $1 mark. So I'm going to do this, and I'm going to zoom in a bit. And so if I were to extend this black line, it looks like it should go, what is the slope here? Let's see. So 1, 2, 3, and then 1, 2, 3, 4, 5. So between that point and that point, up 3. 1, 2, 3, 1, 2, 3, 4, 5. So it looks like I should connect this point with this point. Now you'd use a ruler, not be like, a goof like me, but you would use a ruler here. So you would be able to judge this very accurately. So this should be approximately, so wherever it hits about here, so it's 11, 12, sorry, 10, 11, 12, 13, 14, 15, 16, 17, $1. Let's just see here. So the question says, I'm on B, the cost of the call was $1, estimate the time for the call. So that should be about, what do you say? So 11, 12, 13, 14, 15, about 15 minutes?
Yeah, no, what is it, 14?
So 14 is right here. No, it should be beyond that. It's going to be just over between 14 and 15, at least. Okay. On a test, I am going to see if you used a straight edge and if your line was actually good. Like if you actually extended this properly. I am going to be very picky on a test. Okay, so you need to be very picky and careful when you draw. If it's freehand, and you said something like 13 or 12 or something, you're gonna get it all wrong, totally wrong.
Wait, so
Use
then
a
we use
ruler.
on the test?
Guess, don't round to the nearest minute always, right? Don't round to the nearest minute. You be as exact as you possibly can. I will accept a range. You bring a ruler. Yeah, you bring a ruler. Yeah, you need to bring a ruler for your test.
Okay.
Yeah, bring a ruler. If you don't have a ruler, come talk to me. I have extra rulers. But yeah, you need to bring a straight edge. It doesn't have to be a ruler. You don't have to measure anything, but it has to be a straight edge. So something that you can make a straight line with. Yeah, question? All right, so looking at your papers, it looks like anywhere between 14 and 15 would be totally fine. So anywhere in here between 14 and 15. Okay? So if they said 14, fine. If they said 14 and a half, they said 14.8, they said 15, great. Okay? All right, let's finish this off here. The cost of the call was $150. Estimate the time, $150. Okay, well, we definitely have to extend this, and I think on your paper, the graph is just slightly different, I think. It just looks a little bit different. So 50 cents, $1, so I need to go 1, 2, 3, 4, 5, yep. 1, 2, 3, 4, 5. So you'd have to extend that up, and then extend this over as well. So on your, I don't know, on your paper, where does that end up to be? What are some answers? Shout out some of your answers.
22 minutes.
25.
22, I think sounds good. 25 might be a bit much. I don't know about 25. 16, 17, 18, 19, 20, 21, 22. Yeah, it should kind of end up right around here. So I take anything from 22, 23. 22 to 23, okay? 22, 23. I 20. No, not 21. No, I don't think it should be 21. 22 to 23. All right. Any questions at all about this 4.5 review assignment? Yeah. So for the test, bring a ruler or a straight edge. Please. And a pencil. You're not doing it in pen, right? You're not doing anything in pen. Nothing in pen. Pen is evil. Pen is like a negative slope. Bad. Pen. Okay?